Hi, boys and girls. In this lecture, we will be discussing about quadratic equations in one variable. That means the highest power of the single variable that we are going to talk about is going to be 2, right? So let us talk about one such general quadratic equation. It is ax square plus bx plus c, which is equal to 0. Right now, here as you see that if we talk about the constants, then they are the initial alphabets of English language like A, B, C. And if you talk about the variables, then if we talk about x is the only variable where the highest power of x is 2. As such, it is known as quadratic equation in one variable. Now this implies that there will be two values of x which are going to make the algebraic expression on the left hand side to be equal to 0. So these values which make 0 of the algebraic expression ax square plus bx plus c are known as the zeros or the roots. So as the highest power of x is 2, so like I told you just now, we will be having two roots, right? So this is the speciality of a quadratic equation. Now let's get ahead further and let's try and find out what these roots are going to be. Now in order to find it, we have a formula method, and that was actually given by an Indian mathematician by the name Sridharacharya, right? So we have the name of this rule, this formula, with the help of which we can find out the roots or the zeros, right, to be known as Sridharacharya, right? And then obviously formula. Now what is the formula? The formula is minus b plus minus whole square root of b square minus 4ac whole divided by 2a. So children, this is the formula. So whatever quadratic equation we have, we compare it with ax square plus bx plus c. We get the values of a, b and c, and then if we keep it in this formula, we are able to get to the roots. Now children, there is one thing which is very important here, that is b square minus 4ac. Now this b square minus 4ac is known as the discriminant, right? So next now we'll be talking about the discriminant, and it has its name like this because this is the one which helps in discriminating or in differentiating between the different roots. Okay, now the variable which actually represents the discriminant is capital D, or sometimes it is also written to be the Greek alphabet delta, right? Now the value of this is b square minus 4ac, right? So I'll just quickly repeat all of these things, after which we'll be discussing the nature of roots. Now the first thing here is, when we talk about a quadratic equation, generally it is written to be ax square plus bx plus c is equal to 0, where a, b, c are the constants, right? So here I will write it also so that you can understand it. So these are the constants, right? And if you talk about x, which are the later alphabets of English language like x, y, z, they are the variables. So here we have our variable to be x. Okay, now here I told you that as this is a quadratic equation in just one variable x, the highest power of x is 2, so we expect two roots here, and like I told you, is either known as a root or it is also known as a 0, because it makes the algebraic expression ax square plus bx plus c to be equal to 0. Next now children, if we talk about a formula with the help of which we can find out these roots or these zeros, then it is minus b plus minus root of b square minus 4ac whole divided by 2a. So this is the formula, right? And as it was given by an Indian mathematician, Sridharacharya, so that's why this formula is in his name. Now this is also known as the formula method. Now children, here there is a quintessential entity, and that is b square minus 4ac, right? This is known as the discriminant, that is written by capital D or by delta, a Greek alphabet. Now children, this is the one which actually tends to decide what type of root or what type of zero you're going to have, right? So just look at this formula. We see here that we have plus minus root of b square minus 4ac. So once plus sign is going to be taken, and then we will have a root, and at the other time when you take minus sign, you will get the other root or the zero. Okay, so now let's quickly look up how b square minus 4ac is going to impact the different roots which can be found out. For that matter, if now we talk about b square minus 4ac, that is delta, right? We have a few cases. That is, if delta is greater than equal to 0, then we have the roots to be real, right? So if we have our delta, that is the discriminant, to be greater than equal to 0, like a number 4 or probably a number 0, then it for sure is this, that the roots are going to be real, right? Now after this we have another case, that is, if we talk about this delta or this d to be one such which is less than 0, then we can say for sure that the roots are to be imaginary, right? And another word which is for imaginary roots, right, is also known as complex, right? For that matter, complex is a better terminology, because in higher standard you'll get to study complex numbers, which is a complete group of numbers. Okay, so what I said is what I will quickly repeat, right? That is, here now there is one thing which is going to decide almost everything, that is b square minus 4ac, and as it is the deciding factor, it is known as the discriminant. It is represented by capital D or by delta, and its value is b square minus 4ac. Now if delta is greater than equal to 0, or in other words is positive or even 0, then the roots are to be real, right? And if we have delta to be less than 0, then the roots are going to be imaginary or complex. For that matter, just imagine if you have this root of b square minus 4ac to be something like minus 3, then obviously this is not going to form a real number, and that is why the roots will be said to be imaginary or complex. There are a lot of interesting facts which are about complex numbers, which in times to come we will be discussing in different lectures, right? So do wait for it. Meanwhile, make sure to look up the short which is there in the Instagram, and the profile of the Instagram is there in my YouTube profile, so do look it up, and also you can log into that and look up all the shorts. I'm sure they're all going to be very beneficial. Moreover, if you're really serious and you want to fast track your journey in mathematics, learn mathematics very soon, be it for an examination, be it for some competitive examination, or be it to be able to become a good teacher, right? Make sure that you subscribe to all of this, and there is a form link where you can write what you want to excel in, and then you'll find me coming to you and helping you out, right? So make sure you fill up the form which is there in the description of the video, as well as in the description of the channel, which you'll just get at the top. Okay, now getting back to what I really want to discuss, that is sums on this topic. Now there are other concepts which in times to come I'm going to deal when we have questions. So at this time, children, there is this as the question, which initially I like you people to quickly try out, and after that I will be discussing it with you. If you want a longer duration, then obviously you can pause the video for a longer duration and give it a longer and a better brave try. I'm sure all of you people must be sitting at a place where there is no disturbance and you're not trying to disturb yourself with a electronic gadget like a mobile, a PlayStation, a laptop, a TV, or something like that, right? So when you sit on a table and chair and you do not have any disturbance, that is the time when you'll be able to understand everything clearly and also apply it in times to come. Okay, now let's get to the sum. Here we have in the question, find the set of values of k for which 2x squared plus 3kx plus k is equal to 0 has distinct real roots or has indistinct roots, right? So we can consider that there are two parts to this question. The first is when we've got to find out distinct real roots. So first we will get to it. So now this capital A actually stands for the answer to this question. Okay, now we have the equation to be 2x squared plus 3kx plus k to be equal to 0. Now next thing that we're going to do is we will be comparing this you can say comparing above equation. Such statements, remember, are very important. With what? With the general quadratic equation that we discussed earlier, that is ax squared plus bx plus c to be equal to 0, which actually is going to give you the value of a, b and c, right? So now children, we can say that after comparison we are able to get to a, which is 2, right? We'll get the value of b to be equal to 3k and we get the value of c to be equal to k, right? So after getting these values, we will directly come over to the discriminant. You remember what the discriminant was? Well, the discriminant delta, or you can even represent it by capital D. In different books it is different representations. So that obviously is going to be b squared minus 4ac, which is not going to differ in the different books, right? Because the discriminant delta remains to be the same. Now children, here in accordance with these values we can easily calculate it, right? And if you're to calculate it by keeping these values, we will get the delta for this case that we are discussing here to be b squared, which is 3k whole square, from which we will be subtracting 4 times of a, that is 2, times of c, which is k, right? Now further, when we write this, we will get 9k square, right, from which 8k is going to be subtracted. Now children, remember, we have to find out distinct real roots, right? So we will directly come to the concept of real roots first. So we will say that for real roots we should have the discriminant delta to be greater than equal to 0, right? Okay, so here now we have 9k square minus 8k, right, which is going to be greater than equal to 0, right? Okay, this is the condition to be able to get to real roots. In times to come, I'm going to tell you how to get distinct roots, right? So here children, next what you'll be doing is you'll be taking this k to be common outside, and then we have 9k minus 8, which is inside, and this is greater than equal to 0, right? The first value tells you that k can be greater than equal to 0, and the other value tells you that you have 9k minus 8 to be greater than equal to 0, right? Now children, here we have one thing, that is, if say we now talk about equal to 0, let's see what happens. So by the formula, you remember that the roots were given by minus b plus minus whole square root of b square minus 4ac divided by 2a. So b square minus 4ac is the discriminant, and if we put that to be equal to 0, won't this become equal to 0? That means minus b plus minus root of 0, that is 0, and as such it will become minus b divided by 2a, right? And thus you will just get one root, and that is the case of equal roots. and this is where it becomes indistinct, because if you are to get distinct roots, you have to get two different roots, right? So to be able to get to distinct roots, you don't want b square minus 4ac to be equal to 0, right? As such, here we will change this slightly by doing what? By talking about b square minus 4ac to be not equal to 0 but just greater than 0, right? So here, children, we will now change this a little. You will say here, but for distinct roots, what do you require? You require delta to be just greater than 0, right? Now here, children, we can thus write that we will now have here k, right, times of 9k minus 8, right, which is going to be greater than 0, right? Okay, now after this, what we do is, now children, for this we have two cases. One, when we have k which is greater than 0, and another case which is 9k minus 8 to be greater than 0. Is it true? Really? No, you're making a mistake. That is because when we talk about this value, this is actually going to have three portions. I'm going to show you now. So if we talk about now this to be a straight line which actually represents, say, the real number line, then on it we can talk about here 3 points, right? That is one portion which is, say, where we have k to be 0, and another portion where we have the value of k when we put 9k minus 8 to be equal to 0 to be equal to 8 upon 9, right? Now, can you see the three portions? Yes, you can. So what do we do is we mark the first portion, we mark the second portion, and there's also another portion which is third, right? So now, children, here let's try and keep a value which is less than 0. Now if you talk about this portion is the portion which is positive. Let's see how. If we keep the value of k to be less than 0, let's say we keep it to be minus 1, right? Then here we will get 9 times of minus 1, that is minus 9, and minus 8 will make it minus 17, right? And when multiplied with minus 1, it will become equal to plus, right? As such, if it is plus, that means it must be greater than 0. So this is one of the portions which is required, right? And as such, we talk about this portion to be the portion which is positive, right? And now we talk about the other portion. Remember, we just require portions which are greater than 0, that means positive, right? So if we keep a value of k which is between 0 and 8 upon 9, right, let's check what will happen. So if we keep the value of k to be 1 upon 2, right, then what we are going to get is we will get the value of k to be 1 upon 2, say, and then again we keep the value of k to be 1 upon 2, so this becomes equal to 9 upon 2, from which 8 is to be subtracted, and let's see what happens. This becomes 9 minus 16, right? And 9 and 7 is 16. As such, this becomes equal to minus 7 divided by 2, which is to be multiplied with 1 upon 2, and the product of both of these is going to be negative. That means it will be less than 0. As such, you can't accept it, and that is the reason why what we are going to do is we will just be taking the portion which is on the left hand side of 0, that means the values which are lesser than 0, right? And thus this portion comes out to be negative. Now we'll come over to the portion which is greater than 8 upon 9. Excuse me. So let's talk about a value which is greater than 8 upon 9. Let's keep it to be simple, that is 1. So when we keep it to be 1, let's see what happens. So k is 1, Then we have 9 into 1, that is, again we'll have 9, and then we'll have 9 minus 8 in one of the brackets, and we have 1 outside. So obviously this becomes 1 which is multiplied with 1, and is it not positive? It is indeed positive. As such, you can mark this portion to be positive. Right? Now children, we will quickly remove all of this, and thus you know which are the portions which are to be taken, right? So the portions which are to be greater than 0 are to be taken. So you will take this which is greater than 8 upon 9, and you will take the portion which is less than 0 for getting the value of k times of 9k minus 8 to be greater than 0, right? So here thus you will say that for real distinct roots right, we should be having k to be an element of minus infinity, right, comma 0, and minus infinity obviously cannot be approached. As such, we'll put up an open bracket, and then 0 is again not approachable because there's no equal to sign here. As such, this is one of the portions, and except that we also have the portion which is beyond 8 upon 9. As such, we can write this to be 8 upon 9 comma again positive infinity, right? So 8 upon 9 obviously cannot be reached because there's no equal to sign, and further infinity also is one such which you will not be able to reach. As such, you'll put up an open bracket. So this is what is the final answer, and thus you can say that if you talk about trying to get to distinct real roots, so this is what the answer should look like, right? So I'll just quickly discuss this all over. Here, I'm sure you must have learned a lot of new things, but it is interesting, isn't it? So here in the question, children, we've been told that you got to find out the set of values of k for which 2x square plus 3kx plus k is equal to 0 has distinct real roots. So what you do is you first pick up this equation, and then you compare it with the general quadratic equation, that is ax square plus bx plus c is equal to 0. You get the value of a, b, and c, right? Next, you find out the discriminant, right, by keeping in place of b, a, and c, right? So we get it to be 9k square minus 8k. Now next, children, what we do is, as for real roots, we should have the discriminant to be greater than or equal to 0. So that's why we put it this way, right? And then after that, next, what we do is, rather at this time, this can be removed, right? And then after that, next, what you do is you now talk about distinct roots. As such, we will remove the equal to sign. Now why so? That is because if you talk about the formula, in the formula, if b square minus 4ac is equal to 0, then obviously this will be plus minus 0, or in other words, only b upon 2a will be left out. That is the case when you get equal roots, right? So as such, here we will not be talking about the equal to sign, and we'll be removing it. Now we write it. For distinct roots, we require delta to be greater than 0. So obviously k times of 9k minus 8 is to be greater than 0, right? Now this method that we employed to find out the portions in the real number line which are actually required, we call this to be the method of intervals, right? So here we mark these points considering that this is not an inequation but an equation. So we take k to be 0, or we take 9k minus 8 to be equal to 0, where we get the value of k to be equal to 8 upon 9, right? Now children, to be able to find those portions where this inequality will be greater than 0 or positive, we now talk about 3 portions, right? One on the left hand side of 0, one on the right hand side of 0, and on the left hand side of 8 upon 9. That means between 0 and 8 upon 9, right? Not including both of these, as there's no equal to sign here, remember. And the portion which is beyond 8 upon 9, right? Now we try and check which is going to be positive and which is going to be negative. So if we keep our value of k which is less than 0 like -1, we find that both of these come to be negative. As such, this portion is positive. That means it is greater than 0, right? That means all of this can be taken over as one of the portions. And as you can see, the portion from 0 to infinity, rather minus infinity, is going to be minus infinity comma 0, because 0 and minus infinity both cannot be approached. Now, if you talk about the next portion, that is, if we take a value which is between 0 and 8/9, we took 1/2, you will find that one will be positive and the other will be negative. As such, their product will be negative, which shows that it is less than 0. So it is not one of the regions that we require. So another region that you require is the portion which is beyond 8/9, and that was checked by keeping the value of k to be 1. You can try it out with any other value, right? So for that case, then what happens is we get the value to be all greater than 8/9. So now that can be written as 8/9. Again, we don't put up an equal to sign because there's no equal to sign here, right? And that's why we write an open bracket. That means that is the portion which is not taken. And further, we take this up to infinity, right? And again, as infinity cannot be approached, right, it is something which is in assumption. As such, we'll put up an open bracket here. Now there is one very good thing that you can write here, that is, if say now we talk about this, then we can just write one more thing here. That is, if you talk about this k, you have to remember that k actually is from the set of real numbers. That means all real numbers which are in these portions, they are actually your answers. Now children, next we'll be talking about the second portion of this question, which tells that has indistinct roots. Now if it is indistinct, that means they are to be the same. So in that case, obviously what will happen is delta will become equal to 0. So here you're going to write this, that for indistinct roots, what will you have? You will have delta, right, to be equal to 0. And if delta is equal to 0, here you can now write the equation, as we already have the value of delta, which is k times of 9k minus 8. So k times of 9k minus 8 will become equal to 0. Now this is a very simple equation, isn't it? So one of the values that you will get is k to be equal to 0, and at the other time when you have 9k minus 8 to be equal to 0, then you will get the value of k to be equal to 8/9. So these are two values which are possible when we have indistinct roots, that means equal roots, right? So we can then talk about these two portions, right? So as such, then as this is another of your answers, so I'll put this in a rectangular box so that the teacher can easily identify, and this is how you should also write so that you can get full marks, right? Okay, so now children, next what we do is we will quickly discuss the second part, as the first part has already been discussed. For indistinct roots, it actually means equal roots. So another way of telling this is we are actually wanting to find out equal roots. Obviously equal roots will be the one which will be indistinct, because you won't be able to distinguish among the two, right? And that is only possible when delta is equal to 0. We discussed it earlier, that is b square minus 4ac should be equal to 0, right? And when we put b square minus 4ac, that is our delta, which we already know to be k times of 9k minus 8, right, to be equal to 0, this becomes a very simple equation where you apply the zero product rule, right? And then you either have k to be equal to 0, or you have the value of k to be equal to 8/9, right? So these are the two answers if you require equal roots, or in other words, if you require indistinct roots. So I'm sure you people must have understood this lecture, and if you've been here till the end of this lecture, I really appreciate your effort to be able to understand typical situations. And now that you have understood, so obviously I expect that you obviously must have liked it. So please do give a like if you really like it, and do write a comment as to how this is helping you and what are the concepts that you learned from this. Moreover, if you really want to fast track your journey in mathematics, you should fill up the form which is there in the description of my channel, right? That is my YouTube channel, and there you'll find a form, right? Do fill it and tell me what your problem is, right? And what are you aiming for, be it a competitive examination, be it your board examination, be it any of the other classes, or let's say you want to become a mathematics teacher without much of certificates, right? So there's a journey I can take you to where you will find paradise in mathematics. So bye children, have a nice time. This is Saurabh Kumar Dutt signing off from the Mathematics Helpline, which is always hell bent on helping you out. Bye.